Two of the most powerful companies on Earth looked at the same data and reached completely opposite conclusions. It was the late 1990s. Air travel was exploding. Airports were running out of room. Something had to change. Airbus and Boeing both knew it. Airbus said, "The future is bigger planes." Boeing said, "No, smaller ones." Both companies were so certain they were right that they each bet tens of billions of dollars on it. One of them was catastrophically wrong. And here's the part that should stop you cold. The company that got it wrong spent $25 billion building a plane the world didn't need. And the company that got it right spent $32 billion building the correct plane and nearly went bankrupt doing it. Both sides lost. And somehow the aviation industry is still paying for it today. So how does something like this happen? How did two of the most sophisticated engineering organizations in human history, with armies of analysts and decades of market data, both end up bleeding billions? And who exactly is still picking up the tab? To understand how this happened, you have to go back to a rule that most people have never heard of, a rule that quietly shaped every long-haul airplane built for half a century. It was called the 60-minute rule. The logic was simple. Twin-engine planes with only two engines, couldn't fly more than 60 minutes from the nearest airport. The reasoning was straightforward. If one engine fails over the ocean, you need to reach land before the second one fails too. So if you wanted to cross the Atlantic or Pacific, you needed 3 or 4 engines. That's why the Boeing 747 existed. That's why the Douglas DC-10 existed. That's why Airbus built the A340 with 4 engines. It wasn't really a design philosophy. It was a legal requirement. But engines kept getting more reliable, dramatically more reliable. And in 1985, the FAA changed the rules, allowing TWA to fly a twin-engine Boeing 767 from Boston to Paris. First long-haul overwater flight ever approved for a 2-engine aircraft. The 767 burned 7,000 pounds less fuel per hour than the 3-engine plane it replaced on the same route. Airlines noticed immediately. By 91, more passengers were crossing the Atlantic on twin-engine aircraft than on every 3- and 4-engine plane combined. And the rules kept expanding. 120 minutes from an airport, then 180, then 330. By the mid-2000s, a twin-engine plane could legally fly anywhere on Earth that a 4-engine plane could. The entire reason 4 engines existed in the first place had just been erased from the rulebook. And Airbus, watching all of this unfold, looked at those rules changing and decided to build an even bigger 4-engine plane. Anyway, but before Airbus committed to that decision, Boeing tried to get there first. In 1996, Boeing unveiled designs for a plane called the 747X, a stretched double-decker version of the iconic 747 that could carry over 650 passengers. The biggest version would have had the famous 747 hump extended all the way to the tail. Boeing took it to airlines. Airlines were intrigued. They asked questions. Boeing kept adding features, kept customizing designs to fit different carriers' requests. And then something critical happened. Nobody would actually sign a contract. Airlines liked the concept. They just wouldn't commit to buying it. A Boeing executive later described the situation bluntly. The market was going down, but costs were going up. Boeing's own forecast said maybe 70 to 80 aircraft sold over 9 years, against a development cost north of $5 billion. The math didn't work. In early 2001, Boeing killed the project. Airbus watched all of this happen, watched Boeing pitch a super jumbo, watched airlines balk, watched Boeing abandon it entirely. And then Airbus did the one thing no rational observer could have predicted. In December 2000, 3 months before Boeing officially killed the 747X, Airbus launches the A380 anyway. Initial budget $9.5 billion, firm orders from 6 airlines, and total confidences that the world was about to prove Boeing wrong. The pitch Airbus made was genuinely compelling. The A380 wasn't just bigger than the 747, it was dramatically more efficient per seat. Airbus promised 15 to 20% lower cost per seat than the 747. One A380 replacing 2 747s on the same route, using 1 airport slot instead of 2. At slot-constrained airports like London Heathrow or Tokyo Narita, where landing rights are worth tens of millions of dollars each, That argument was almost impossible to dismiss. They used the same playbook Boeing had used to sell the original 747 to Pan Am back in the 1960s. Sell to the prestige carriers first, and everyone else will follow out of competitive pressure. Emirates signed on, Singapore Airlines signed on, Qantas signed on. When carriers like those are buying, you feel like you're falling behind if you don't. But while Airbus was celebrating those early orders, Boeing was failing its way into something far more dangerous. On March 29, 2001, the exact same day Boeing confirmed it was killing the 747X, the company unveiled a new concept called the Sonic Cruiser. It looked like something from a science fiction film. Delta wings, a canard design, cruising speed just under the speed of sound, around 225 passengers. The complete opposite of the A380 in every dimension. Where Airbus was betting on scale, Boeing was betting on speed. Some airlines were interested. Virgin Atlantic's Richard Branson said he expected to order between 3 and 6. American Airlines showed serious curiosity. Boeing laid out a 5-year development plan. Then September 11th happened. Air travel collapsed overnight. Airlines lost $13 billion in 2001 alone, and another $11 billion the following year. 1,000 commercial aircraft were parked, and suddenly, nobody cared about speed. Nobody cared about size. Airlines wanted one thing and one thing only: efficiency. Every dollar of fuel burn mattered in a way it never had before. Boeing held on to the Sonic Cruiser for more than a year, but by December 2002, it was dead. And here is where something remarkable happened. Boeing didn't start over. All the technology they developed for the Sonic Cruiser, carbon fiber composites, new engine architecture, advanced avionics, they took every piece of it and redirected it into a completely different kind of airplane. Not fast, efficient, not big, right-sized. They called it the 7E7. Then the Boeing 787 Dreamliner, 200 to 300 passengers, 20% less fuel than anything in its class. Designed not to funnel passengers through massive hub airports, but to connect cities directly, point to point, Portland to Reykjavik, Austin to Amsterdam, Nashville to London, routes that could never fill a 500-seat airplane. In 2004, Japanese carrier ANA became the launch customer with 50 aircraft on order. The plane that would eventually kill the A380 was now in development. And while Boeing was quietly building the future, Airbus was building the most expensive wiring problem in aviation history. Each A380 contains 530 kilometers of wiring. That's over 300 miles of cables running through a single airplane. The wings were built in the United Kingdom. Fuselage sections were built in Germany and France. The tail came from Spain. Everything was shipped by road, sea, and specially modified aircraft to the final assembly line in Toulouse, France. When the German-built wiring harnesses arrived and workers attempted to connect them to the French-built fuselage sections, they didn't fit. Different engineering teams had been working with different versions of the same design software. Thousands of cables that were supposed to simply plug together didn't match. The fallout was severe. 2 full years of production delays. The development budget, originally $9.5 billion, began climbing toward $20 billion. Airbus's parent company EADS saw its stock drop 26% in a single day. Roughly $5 billion in a market value erased before the market closed. The first A380 finally reached Singapore Airlines on October 15, 2007, 19 months behind schedule. And here's the thing that makes this story genuinely complicated. As a plane, the A380 actually worked beautifully. Singapore Airlines reported it burned 20% less fuel per seat than their retiring 747 fleet. Passengers loved the quiet cabin, the extra space, the bare and showers in first class. Pilots said it handled remarkably for an aircraft of its size. The airplane was impressive. The business case was a disaster. Lufthansa deployed its A380s on the Frankfurt to New York route and confirmed what Airbus had promised. Cost per seat dropped significantly. But here's what Airbus's sales pitch didn't mention. When you put 500 seats on a single route, you have to cut ticket prices to fill them. Cost per passenger went down, but revenue per passenger went down almost as much. Lufthansa was essentially breaking even, with twice the operational complexity of a smaller aircraft. And for airlines that had only ordered a handful of A380s, the situation was far worse. Emirates CEO Tim Clark, the man who became the A380's single most important customer, was remarkably candid about this. He said the A380 was a misfit for Air France. They had only 10 of them. Running a subfleet of 10 of the biggest airplane ever built is an operational nightmare. Maintenance costs stay high. Crew training costs stay high. Spare parts procurement stays high. The economies of scale that made the A380's economics work only appeared at genuine volume. The problem was only Emirates had genuine volume. Everyone else bought 10 or fewer, and most of them were quietly losing money on every flight. The financial structure of the A380 program had a fatal flaw buried inside it. Airbus needed somewhere between 200 and 300 aircraft sold to break even on development costs alone. They ultimately received 251 total orders, barely enough if every single one had been delivered and paid for. But dozens were canceled before delivery, meaning the program almost certainly never recovered its full development investment. Total program cost estimates range from $25 billion to $30 billion when production overruns, software delays, and compensatory payments to airlines for late deliveries are fully accounted for. And then came the engine shock that changed everything. When Airbus was finalizing the A380's launch around 2000, they asked GE Aviation and Rolls-Royce a direct question. Is anything better coming? Are there new engines on the horizon with meaningfully better fuel efficiency? Both engine manufacturers said no. Nothing significant. Not for years. Airbus's head of sales, John Leahy, later said the company was blindsided by what happened next. Their engineers had explicit assurances from the engine manufacturers that no step change in fuel performance was imminent. 3 years later, before a single A380 had been delivered to any airline, GE and Rolls-Royce announced new engine technology delivering 15% better fuel efficiency. And those engines were going on the Boeing 787. The A380 wasn't even flying yet, and its engines were already a full generation behind its primary competitor. Every airline doing a wide-body comparison could now see a clear 15% efficiency gap. And that gap wasn't closing. It was widening as 787 operators accumulated data on real-world fuel savings. Then oil prices made the situation brutal. Jet fuel climbed from around $50 per barrel in 2003 to $147 per barrel by mid-2008. Operating 4 engines at those prices was economically punishing in a way no spreadsheet from 2000 had anticipated. The Airbus A340, also 4 engines, also designed for long haul, became effectively uneconomical almost overnight. Airlines began grounding them by the dozen. The A380, while more efficient per seat than the 747, was still a 4-engine aircraft burning massive total fuel volumes. The cancellations began stacking up. FedEx pulled their order for the A380 cargo version. 10 aircraft gone. UPS canceled their freight orders. Airbus shelved the entire freight program. Virgin Atlantic had ordered 6 A380s and never took delivery of a single one, eventually walking away from the contract entirely. The estimated cost to Airbus of the freight program collapsed, combined with early cancellation penalties paid out to airlines delayed by the wiring disaster, conservatively $3 to $5 billion in direct financial damage, separate from the development cost overruns. And then there was a problem nobody had anticipated. There was no secondhand market. When an airline retires a Boeing 737 or a 777, another carrier buys it. Planes get a second life, sometimes a third. The asset holds value. When Singapore Airlines retired their first A380s after just 10 years in service, practically brand new by aviation standards, nobody wanted them. They were scrapped. Because only around 20 airports worldwide have the infrastructure to handle an A380. There simply aren't enough potential buyers. The addressable market for used A380s is, effectively, the same 10 or 15 airlines that could have bought them new, most of whom had already decided they didn't want them. The aircraft had no exit. It was a one-way bet with no hedge. There is one airline that defies every part of this story, one carrier for whom the A380 wasn't a disaster, wasn't a financial trap, and wasn't a strategic mistake. Emirates. And understanding why Emirates is the exception explains everything about why everyone else was the rule. Most major airlines operate a mix of domestic and international routes. They connect smaller cities to bigger cities to each other, building hub and spoke networks that serve hundreds of origin points. Emirates does none of that. They have one hub, Dubai International Airport. Their entire business model is built around funneling passengers from every corner of the world into that single airport and then back out again. Look at where Dubai sits on a globe. It's roughly halfway between Europe and East Asia, a few hours from the African continent, directly connected to the Indian subcontinent. If you're flying from London to Sydney, or from Lagos to Singapore, or from Frankfurt to Bangkok, Dubai is geographically almost directly between you and your destination. Emirates built their entire business around that geographic accident, and when your entire model revolves around moving the maximum number of passengers through one constrained hub, a 500-seat airplane isn't just useful. It's structurally optimal. At peak operations, Emirates was running 8 A380 flights per day to London Heathrow alone. At a slot-constrained airport where a single landing slot can be worth $50 million to $100 million on the secondary market, getting 500 passengers on one movement instead of 250 is a real, measurable financial advantage. And Emirates had the scale to make the economics work in a way no one else could. Tim Clark didn't buy 10 A380s. He bought 123 of them, nearly half of every A380 ever built by a single airline. At that volume, maintenance costs per aircraft fall dramatically. Crew training is fully standardized across a massive fleet. Spare parts procurement becomes efficient. The catastrophic unit economics that crushed Air France running a subfleet of 10 simply don't apply when you have over 100. But here's what that created: a single point of failure for the entire A380 program. One airline was responsible for nearly half of all orders. When Emirates was growing and ordering, the program had momentum. When Emirates hesitated, the program stalled. And when Emirates finally signaled it would stop ordering, there was nobody else to fill the gap. The A380 didn't have a customer base. It had Emirates. And that was, structurally, the same thing as being one announcement away from collapse. In February 2019, Airbus announced the end of A380 production. The trigger, Emirates reduced a planned final order from 53 aircraft to 14. Without that volume, the production line was no longer economically viable to keep open. The program that had consumed $25 billion was formally terminated. The last A380 was delivered in 2021. There is one more layer to this story that goes beyond the airplane itself: the infrastructure trap that the A380 built around itself. The A380 is roughly 30% larger than a 747 in terms of wingspan and weight. That doesn't sound catastrophic until you map out what it means on the ground. Runways need to be wider to accommodate the wingspan. Taxiways need structural reinforcement to bear the landing weight. Gates require double jet bridges, one for the main deck, one for the upper deck, adding millions in construction costs per gate. Baggage systems need to handle the volume of 500 passengers per flight. Even the engine exhaust wake during taxi is powerful enough that airports had to redesign ground routing to prevent smaller aircraft from being caught in turbulence behind a taxiing A380. The Port Authority of New York and New Jersey spent $175 million modifying its airports, primarily JFK, just to accommodate A380 operations. That was a single airport authority in a single city. Multiply that infrastructure commitment across every airport that wanted to handle the plane. The global aviation system spent hundreds of millions of dollars collectively preparing for an aircraft that most airlines ended up not buying. And this created a trap that fed on itself. Airlines didn't want to order the A380 unless airports could handle it. Airports didn't want to spend hundreds of millions on modifications unless airlines were going to fly the plane. Each side was waiting for the other to move first. The Boeing 787 had none of this problem. It fits at any gate designed for a 767 or similar aircraft. No runway modifications, no special jet bridges, no infrastructure investment from airport authorities. An airline could order a 787, receive delivery, and start flying new routes tomorrow. And the destination airport wouldn't have to change a single thing to receive it. The A380 didn't just need to win on economics. It needed airlines, airports, regulators, and ground handling systems to all reorganize simultaneously around one aircraft. The 787 just needed a parking spot. One of these strategies was built to scale. The other was built to stall. Step back from the numbers for a moment and look at what this story actually is. Boeing read the future correctly. They understood that the era of massive hub-and-spoke aviation, funneling millions of passengers through a handful of mega airports on enormous planes, was giving way to something different. Direct connections, right-sized aircraft, efficiency over spectacle, and they bet the company on that vision. Airbus read the future incorrectly. They believed airports were the constraint, that hubs would only get more crowded, that bigger planes were the inevitable solution. They bet $25 billion on a world that was already changing direction. By almost any measure, Boeing won. The 787 has received over 1,400 confirmed orders. The A380 received 251. Boeing's plane outsold Airbus's flagship by nearly 6-1. New routes made possible by the 787's range and efficiency have opened connections that genuinely change travel patterns. Perth to London nonstop, Auckland to Chicago, Osaka to Seattle. The 787 didn't just win a market contest, it restructured how the world moves. And yet, Boeing nearly destroyed itself in the process. The 787 came into service 3 years late. In 2013, its lithium-ion battery systems began catching fire, and the FAA grounded the entire worldwide fleet, the first complete fleet grounding since the DC-10 in 1970. Then came years of quality control failures, manufacturing defects, delivery halts, a near-complete production stoppage from 2021 to 22. Boeing has spent an estimated $32 billion on the 787 program, and by most analyses, has still not broken even. They need somewhere between quiet 300 and 2,000 total sales before the program turns a profit. And that's before accounting for the 737 MAX disasters in 2018 and 2019, which killed 346 people, grounded the fleet for 20 months, and cost Boeing a documented $20+ billion direct financial impact, with the full reputational and legal costs still accumulating today. The company that got the future right came within a serious distance of collapse. Airbus's story runs in a strange parallel. After the A380 launched and the early orders came in, Boeing unveiled the 787 and airlines began requesting that Airbus build a competitor. Airbus's official response for a remarkable period of time was that they didn't need to. They called the 787 a reaction to their own A330 and essentially dismissed it. Airlines pushed harder. Airbus eventually produced a proposal they called the A330-200 Lite, essentially the same A330 fuselage with updated wings and engines bolted on. A minimum effort response. Airlines rejected it almost universally. Singapore Airlines CEO made the logic plain. If Airbus was already designing new wings, a new tail, and a new cockpit, they might as well design a new fuselage too. Qantas declined the proposal outright and ordered 787s instead. Forced back to the drawing board, Airbus announced the A350 XWB in July 2006, a completely new aircraft, new composite fuselage, wider cabin, new engines genuinely designed from scratch to compete with the 787. Singapore Airlines ordered 20 within 4 days of the announcement, but the forced redesign cost Airbus 2 years and ballooned the development budget from approximately $5 billion to over $15 billion. The plane Airbus didn't want to build, the one they were embarrassed into designing, went on to receive over 1,500 orders, outselling the A380 by 6-1 and becoming one of the most commercially successful wide-body aircraft in history. The A380 got 251 orders and ended production. The A350, which Airbus initially insisted wasn't necessary, saved the company. Here is the insight that ties the entire story together. Airbus's mistake didn't kill them. It cost them approximately $25 billion in industrial tuition. But the A350, the plane they were shamed into building, generated enough commercial success to absorb that loss and then some. Boeing's correct prediction didn't save them. Being right about the future doesn't guarantee profit. Execution matters. Quality control matters. Safety culture matters. And Boeing's failures in all three areas have cost the company something harder to quantify than money: the trust of regulators, airlines, and the traveling public. Both companies placed enormous bets on a future they each partially understood. Airbus understood that airports would remain constrained. They just underestimated how dramatically efficiency would change which solution airlines would choose. Boeing understood that efficiency and direct routes were the future. They just underestimated how brutally difficult it would be to actually build that future airplane. The A380 didn't die because it was a bad aircraft. Passengers loved flying on it. Pilots loved operating it. Emirates will keep their fleet flying well into the mid-2030s, and every one of those flights will be full. It died because the world changed, and the economics of that change weren't compatible with what the A380 required to survive. And in a final irony, the company that built the wrong plane survived because someone else forced them to build the right one. The company that built the right plane is still paying for it. Aviation is a business where being right and making money are two entirely different things. And the $57 billion combined that Airbus and Boeing spent finding that out is the most expensive lesson in the history of commercial aviation.
Well, I'm quite sure that is, well, once again, thank you for watching this video, and we really appreciate you for coming along. And please, I want you to write in the comment section what you think about this documentary, what you think. Well, I'm sure that by now the two companies has learned from their mistakes, and as a matter of fact, I know one thing, when it comes to the business, you have to make some mistakes before getting it right. Of course, sometimes there might be some really expensive mistakes, but then today I believe that Airbus and Boeing are better now with such experience they've got. I think they are better now, and they now know what the people, their customers or their clients need for their you know, for a smooth business transaction. And so sometimes this also can be translated to a real life scenario where now we know what works and what does not work, and that is how it should be. Sometimes bigger does not mean better, and sometimes smaller too does not mean better. You just need to um, find a middle ground, something hybrid that at the end of the day you still get profit, and then you've still done well. Of course, I feel they both went the extra mile, thinking they were trying to satisfy the customers. But unfortunately, that was a very wrong bet. A very wrong bet, I tell you. A very wrong bet. And such should not be. It's not something that should be played or tried with. But I'm sure, like I said, we all make mistakes, even as businessmen. But the biggest mistake is the mistake of not learning from our past mistakes. And that's it. Yeah, I believe so. That's it. So just write in the comment, tell me what you think about the video and what you learned from the video. If you're a business person, I know you know what I'm talking about. And so that's it, yeah.